How much money is hissing away in your plant during every shutdown? This not only affects the life of our equipment, but it also affects our company's bottom line. In this video, we're going to talk about how do we establish a baseline to know how much energy our pneumatics are consuming, then how easy it is to justify the cost of those repairs once you have that information. We've been building out our pneumatic trainer and we had gotten it to where it was doing its electro-pneumatic sequence and exercise. And in the last video, we actually disabled the actuator just for this exercise, and we made it where it runs a specific number of sequences. That way we'll know how much is each one costing. So if I start auto mode here, it's going to grab the part, pick it up, move it over, open back up, and retract back. And we are getting the accumulated flow on our flow meter. And right now, after 10 cycles, our system will start. Now, this is very important that before, even though, especially on our true automation projects, but also on this exercise, that we establish a baseline before we do anything. And I did not realize the importance of this until actually we were hosting a pneumatic training here. And that's the first thing they said is before you touch anything, get you one of these flow meters, cut it into your line, and just walk out there in the morning, write the value down, walk out there in the evening, and write that value down. That way you know how much that is costing the company. Because while to a manager, the air leaks in the plant are annoying, they don't realize the dollar value of those air leaks. And good example, kind of, even in the here, we have great lighting in the training center. And I did it on my dime. And really at the time, I wasn't expecting anything. I just wanted better lighting so y'all would have a better experience when you came here. But afterwards, I got thinking, I'm like, wow, I cut the lighting bill in here probably down to 20% of what it was before. Now, if I had established that cost of that lighting beforehand, I'd have something to go back to the landlord and be like, hey, I'm saving you this much money per, month. You think you could do this? I have no leverage. It just looks pretty now. So we want to establish what it's costing us today. Now we're going to do this one a little bit backwards because your system is brand new. My system is brand new. We're going to establish how much is it costing us with no leaks. And then we'll kind of build up to what type of leaks cost us more. And so all I'm going to do is I'm going to write down here, I've got no leaks, and I'm going to write down my start value here. So my start value is 20.8. And for now, it doesn't even matter what that 20.8 is, as much that is the value we have. And then I'm going to start another cycle here, and it'll run through 10 cycles worth. So that was 10 cycles. And now it says that I'm at 22.2. So I'm going to write down 22.2. And so 22.2 minus 20.8, that's going to be what? 2.4? Is that right? Yep, 2.4. Now, we may want to do a couple of these because I don't know that my cycle is big enough. So I'm going to do this a second time just to see, is there a lot of variation? How accurate are we? Speaking of which, the air compressor just kicked on. Did that affect us that much? Probably not, but I just want to make sure that we're getting a pretty good repeatable value here. And this time we are at 23.6. And so I do my math on that one. Apparently I didn't do it. Okay, well, folks, here's why we need a calculator, because either my math is way off or y'all probably already corrected me in the video and told me I didn't know how to do math, which very well may be true. 22.2 minus 20.8, that is 1.4. I said 2.4. And then now it's 1.4 the second cycle. So we're getting a good amount of repeatability. That's the main thing I wanted to see is how much it varied. All right, so now what we're going to do is I have a small pinhole in this airline. It's less than a 30-second hole. And I'm going to pop this retract off, and we're just going to pop the short piece of tubing out. I'm going to put that one in its place. And then we're going to run another 10 cycles. Now, first of all, I immediately observe, and you probably observe, one, it's running fast. Now, we could argue that that's better for production, but my arm's on this table, and I can physically feel it pounding now because this air leak is before this flow control. So most of that air is going out that side, and it is jarring this system significantly harder. So before we even talk about energy consumption, we are pounding this system now. But we started out at 23.6, and now we're at 25.1. And this time I will use my calculator instead of my head, apparently. So 25.1 minus 23.6. So that small little air leak, it may not seem like a big deal, but it's taken us from 1.4 to 1.5. That's a 7% increase in energy consumption just based on that small little pinhole. Now, let's talk a little bit about programming now and how simple programming could save us money. As this system has been sitting, in fact, I should put a timer on it. We'll use a stopwatch, but it's been sitting for quite a while. It's not using any energy. Now, the reason it's not using any energy is because all of our solenoids currently are de-energized. We're not pressurizing these all the time, and that includes our up solenoid. So if I switch this over to hand mode and I press the up solenoid, it does go up. I'll let off of it. It stays up because we have that closed center valve that we talked about earlier in our videos. Now, this one is the extend of the cylinder. So even though it has that pinhole in it, since we're not firing it all the time, we're saving quite a bit of money. Now, just let's, before we even start talking about modifications to see what we could do to it, let's just think about it if we just had it extended right now. Press and hold that, 2, 3, 4. Okay, let me even zoom in a little bit because, yeah, this is important that we see. We're just hissing away dollars simply by having the solenoid energized all the time. So now I want to see how much more would it cost us with the single leak if I wasn't de-energizing those cylinders. Let's go look at our truth table that we've done earlier in this video to figure the sequence out. And if we go up here, our extend solenoid is number 9. So in our outputs, we're only firing number 9 in step 40. Now, 70, that's when we actually retract it again. So what a lot of us will do, we'll keep those solenoids energized, even though they don't need to be. And so 50 and 60, the cylinder is extended, but I'm only firing that extend in step 40. So if we go look at our program here, if we go in, we edit this, I'm going to put a branch around this equal to, and we're going to make it where we keep our solenoids energized all the time. So I'm just worried about this one right here, just so we can talk about the cost of it. So we're actually extended in 40, 50, and 60. And let's finalize that. And so for this one, I'm just going to call this small leak, and I'm going to put plus extend. That way I know that, oh, we're extending that for longer. And we're going to start at 26.1. And first I'm going to go ahead and retract my cylinder. I'm going to bring that back down. And now we'll go and we'll do 10 cycles this way. And I can feel that retract in the table now. It's much harder now because we're leaking on that flow meter, so it's not able to regulate the flow nearly as well. All right, and so we're going to end at 28. And 28, After I did that basic math, I felt like I need to do them all on a calculator, but I think I got this one. 28 minus 26.1, that's going to be 1.9. So just looking at our numbers, our no leaks, it took 1.4. And there was a second no leak just to make sure. Our small leak, that took us to 1.5, roughly a 7% increase. But look at this. Our exact same leak, but keeping our solenoid energized, even though it was already at the position it needed to be, that brought us up to 1.9. That is a 35% increase in energy consumption from a small pinhole to that point. But more importantly, here's where just a slight bit of programming change from our programmer, we only extended it when it needed to move, to holding it all the time. That was a 26% increase in energy consumption. Now, the next one that I really want us to talk through is just that idle hissing. How much does it cost us? So a good run on this machine takes, we're calling it 1.4 units, because really the units don't matter as much on this as much as small things we can do to reduce this. But so on ours, how long does it take us to get 1.4 units worth of leak out of this? So we're at 28 right now. I'm going to switch over to hand. Probably should use a timer, but I'm going to use a stopwatch here. So I got my in hand, and I'll hit the extend, and I am looking for 29.4. So start. So roughly a minute of air leak is wasting the energy to make one cycle on this. All right, let's try to put some dollars to this, because probably even if you've done this exercise the same as I have, you can kind of hear it, but it doesn't seem like a big deal. Well, this air leak, according to leaking roughly 1.9 liters per minute of air here, it's costing us 61 millionths of a dollar a minute. Now, first of all, you're kind of like, oh, well, what's the big deal of that? That's roughly 0.37 cents per hour. Still not a big deal. But over the year, that's $32.14. At that point, we can probably pay someone for this little pinhole leak to go out there and fix the air leak. So now let's make our air leak a little worse. Now, still, I would call this a mild air leak, but it's about an 1/8 inch hole. We're not even to a size of a gash in a line yet. And I think we're at 29.4 is going to be our beginning spot. And I'm going to call this our 1/8 leak. Now, currently we still have our poor programming, so I'm going to put plus the extended because we're extending way too long. So now I'll go ahead and bring my retract back. One, you see how hard that slammed. And here, never mind the air leaks. We're going to beat our machine to death just based off of it not being able to regulate the flow correctly. But then we're going to go ahead. We're at 29.4. We're going to make 10 cycles. All right. Hopefully, the operator may report it now. You hear how hard it's slamming it, though. Now, then again, though, it is still running. Is the operator actually going to report this? So we ran 10 cycles, and now we're at 32.3. So 32.3, since I did so embarrassing on my math earlier, we'll go ahead and plug that into a calculator. And 32.3 minus 29.4. So now our air leak is 2.9. And now is the first time I would say in a quiet room we could hear it. But from our original, we are now running double the consumption just based off this. So now let's see how much this is costing us per minute. So right now I'm at 32.3. And I'm going to reset my stopwatch. And I'll go to manual mode. And I'm going to press and hold my extend for 1 minute. Let's think about it. On a noisier system, I don't know how bad that sounds on the mic, but it's loud here. But in a noisier environment, do we actually hear the sleet or is it just noise in the plant? So in 1 minute, we ended at 42.9, and that means we consumed 10.6 liters in that amount of time. So at 10.6, we're starting to talk about some real money. Our machine is still functional. That is going to be 0.00034 per minute, or roughly 2 cents per hour, or cumulatively every year, that's $179.48. Now, our machine is still running. This is only one small machine. Are we going to give it that much attention? Okay, so now we're going to bump it up a little bit more. Because unfortunately, typically, we don't get a call until the machine is not running. So when is this machine clearly going to be showing an operational issue, and how much has it cost us before that operational issue? So now I'll go ahead and retract my cylinder, and boy, that was a hardcore retract there. And now we turn switch 3. Okay, so this air leak is too much for it to actually function. So now let's think about it programmatically. What could we do to save money on our machines? So I'm going to go back to the one before. It was noisy, but we were still functional. And we'll go ahead and bring that cylinder back down. And we're going to go ahead and give it one more run. So we're at 44.9. It's going to be our start on this one. And I'm going to call it leak that will run. And then we'll run 10 cycles. And it's clearly slamming hard. I mean, I would say the mic is probably picking that up now, but this table that's hammering when it comes back. And so we used 47.7 during that time. 47.7. So in the 47.7 minus 44.9, that is 2.8, which is roughly what it used last time. Okay, so now let's modify our program slightly for this. Is initially we were only extending when we needed to extend. How much money can we save if we're not leaving our solenoids on all the time? So let's go back into our Studio 5000 program. Remember, I added the step 50 and 60. All we're going to do is take those back out. This machine is still going to function exactly the same as it did before. So my start is 47.7. And we'll go ahead and run 10 cycles. Still got a very harsh retract because of the leak. And we're going to end at 50.0. And so 50 minus 47.7, that's going to take us to 2.3. So simply based on a small modification to our program, we reduced the cost of that energy leak by nearly 18%. And this is going to continue to scale up on our system. So I don't know how you really figure out the cumulative cost of this, especially after seeing it. And here's where this exercise was enlightening to me, because really I was thinking about it. We establish how much our leak is costing us. We put it on there, and there would be a simple math equation, which we did have to do an energy reduction on it. But once we consider that hammering, what are we doing to our system just based off the air leak and the change in the performance of it? So first thing, get you some of these. This has really been a good exercise, and let's put them on some of the machines. I'll probably put on a few of them in here, and we're going to talk about some different ways that we can manage our air and manage our leaks. Now, if you haven't been following along with this pneumatic training series, then here's a link with some really helpful videos. We'll see you over there.